What if someone suddenly asked you to solve the cube root of this huge number without a calculator? Well, I'm gonna solve this problem in less than 5 seconds. This is about 1,000. Of course, this is a fast answer, and although it is an approximate answer, that's a very good approximation indeed, as we are going to find out. But how do I know that? Well, we have here inside the cube root a number with 9 digits. It is almost 10 to the 9, which is 1 billion. And 10 to the 9 raised to 1/3, which is the same as the cube root of a number, this is obviously 10 to the 3rd, which is 1,000. But since this number is not 1 billion, it is less than 1 billion, then the answer is approximately equal to 1,000, but it is less than 1,000. Now, to make it easy, let's do it again a little bit slowly. We know that 10 to the 3rd is 1,000, 1 followed by 3 zeros. 10 to the 6th is 1 million, 1 followed by 6 zeros. And 10 to the 9 is 1 billion, 1 followed by 9 zeros. And the cube root of 1 billion, 10 to the 9, is, you multiply 9 and 1/3, the result of that is 3, 10 to the 3 is 1,000. Okay, so that was an approximate answer, but we want an exact answer, an exact value. Let's proceed rewriting this equation in a different form. Let's raise to the 3rd power both sides of this equation. So 1,000 cubed is 10 to the 9, or 1 billion. This is 1,000 times 1,000 times 1,000. So our goal is to raise the number that we are looking for, the answer that we are looking for, to the 3rd power, and then try to obtain the number inside the cube root. Now, if the answer is less than 1,000, let's try 900, because it is easy to calculate the cube of 900. What is 900? 900 is 9 times 100, of course. So the cube of that will be the cube of 9 times the cube of 10 squared. So 9 to the 3rd power is 9 squared times 9, 81 times 9. And that is 729. 9 times 1 is 9, 9 times 8 is 72. And 10 squared to the 3rd power is a million, 10 to the 6th. So the answer will be 729 times 1 million. Okay, this number is less than this number, 991 million and something. So the number that we are looking for is in between 900 and 1,000. The number that we are looking for to the 3rd power is equal to this number inside the cube root. And we conclude, we can see that the answer is much closer to 1,000 than to 900. But again, what is the exact value for that? Well, there is a very important information available that we're going to use now. The last digit of this number. The result, the answer, is a number which its cubic has a last digit equal to 3. That's the idea. The cube of the number that we are looking for has a last digit which is equal to 3. So, what number raised to the third power has a last digit 3? Well, it's not 1, because 1 raised to the third power is equal to 1. So the last digit is 1. It's not 2 as well, because 2, or all even numbers raised to the third power, the result will be an even number. So it's not the case as well. We are looking for the last digit of our number, which raised to the third power will result in the last digit 3. And it's not 0 as well, of course, because 0 raised to any power will be still 0. And it's not 9 as well, because we already know that 9 to the third power is 729. The last digit is 9. And it's not the case, again. Well, it's not 3 as well, because 3 to the third power is 3 squared, 9 times 3, which is 27. The last digit is 7. So it's not the case. And it's not 5 as well, because 5 raised to any integer power will be 5. The last digit will be 5. So the last remaining possibility is 7. But let's verify. 7 to the third power is 7 squared, 49, times 7. 7 times 9 is 63, and 7 times 4 is 28, plus 6, 34. So 3, 4, 3. The last digit is indeed 3. So we are sure that the last digit of our number, of the answer, is 7. This is a very important information. So the answer is very close to 1,000, and the last digit is 7. What is that? 907? 917? And so on, up to 997. Those are the possibilities. And since the answer is very close to 1,000, maybe, probably, it is 997. It is much close to 1,000 than the other possibilities. Let's verify. You can proceed calculating 997 times 997, and the result, multiply that by 997. This is very hard work. But let's proceed with another important information here. We know that the cube of a sum is given by this expression. You can demonstrate that very easily. And the cube of the difference is this one. Again, you can demonstrate that very easily. You don't need to memorize that. You can demonstrate that. But of course, if you use it very often, you will memorize easily these expressions. So now, you can see that 997 is 1,000 subtracted by 3. Why am I writing this number as 1,000 subtracted by 3? Because then it is easy to calculate the cube of 1,000 or the cube of 3. It's not easy to calculate the cube of 997. But it is to calculate the cube of those two numbers. So let's proceed with that. The cube of A, so in this case, A is 10 to the third and B is 3. So the cube of A is 10 to the 3 raised to the third power. So this is 10 to the 9. The next one, minus 3 times B. B is 3 as well. So 9, 3 by 3 is 9, times A squared. A is 10 to the third, so 10 to the 6. Plus 3 times B squared. B is 3. B squared is 9. 9 times 3 is 27. So plus 27 times A. A is 10 to the third. Subtracted by B cubed. So this is 3 cubed, which is 27. Now let's rewrite these two numbers using a factor 10 to the 6. So here is 10 to the third times 10 to the 6. Let's write this factor 10 to the 6, and the remaining term will be 10 to the third subtracted by 9. And here you see this is 27,000 subtracted by 27. So the result will be 26,973. 1,000 subtracted by 9 is 991 times a million, so 991 million plus this term, and the result is 991,026,973, which is the number inside the root. So instead of this huge number, we can write 997 to the third power. This power will cancel out with the cube root, and the answer is 997. Okay, but there is another solution, another way to solve this problem. Let's see. You can work through these steps backwards, in reverse mode. Usually, when you are dealing with a cube root, then you may guess that the number inside is the cube of an integer, because the third power will cancel out with the cubic root, and then the remaining term will be the integer that you are looking for. And probably you can write the number inside the root as the cube of a sum or the cube of a difference. Then the procedure is, let's write this number as 991 million plus 26,973. And now you need to be a little bit magic here and recognize that this number is 1,000 subtracted by 9 times a million. And let's repeat this number again. And then more magic here, and you will see that this 26,973 is the same as 27,000 subtracted by 27. And you are going to write this as 10 to the third times 10 to the 6, which is 10 to the 9, subtracted by 9 times 10 to the 6. And now you just wrote this number in a form which is similar, actually, which is in this form here for the cube of the difference. A cubed subtracted by this number plus this other number subtracted by the cube of 3. So this is the cube of 1,000 and the cube of 3. And then, since you recognize that you just wrote this number in this form, then you will, of course, you will verify if indeed it is in this form, and then write this number as the cube of this difference. And of course, 1,000 subtracted by 3 is 997, and then you just solve the problem using this dirty solution. Thank you.